Hi, we're going to talk about what second graders in College Station ISD will be doing in math during this first 9 weeks. This is actually part 3 of the series of videos about second grade math the first 9 weeks. So if you're watching this but you haven't watched part 1 or part 2, you might want to go out and find those videos on our YouTube channel and watch those also. So here is an overview of what second graders in College Station ISD will be doing in math during the first 9 weeks. They're going to start out by solving addition and subtraction problems up to 20, and that was covered in part 1 of the video. They're going to use attributes to classify 2D shapes and 3D solids and to review what they learned in first grade about telling time, and that was part 2 of the video. Then they're going to use the non-standard algorithm to solve one-step problems with up to 2 two-digit numbers, and that's what we're going to talk about in this video. So they're going to add up to 2 two-digit numbers and subtract two-digit numbers using mental strategies and algorithms based on knowledge of place value and property of operations. So I want to point out, we're really focused on kids developing mental strategies and facility with numbers. And so we're going to do that by talking about algorithms. And when I was in school, and maybe when you were in school, we only used one algorithm, the standard algorithm or traditional algorithm, where you stack the numbers on top of each other, and if you add 5 and 8, you put a 3 under the ones place and carry a 1 over to the 10. The problem with that was a lot of times we really didn't talk about the fact that that's not just a 1, it's 10. And so the place value aspect of addition and subtraction was really lost a lot of times. And it was a procedure that was just memorized and not really well understood by a lot of the people who used it. So now we are not starting with the traditional or standard algorithm. We are starting with a variety of algorithms. And an algorithm is just another word for procedure or method or strategy. And you notice that it's not just algorithm, it's algorithms, plural, because we want our students to be able to use multiple strategies and multiple methods and multiple procedures to solve these addition and subtraction problems and to maintain the place value aspect of numbers and to really understand the properties of operations. And we don't require that the students memorize the properties of operation and be able to regurgitate them. We want them to be able to understand those properties and to be able to use them. So they're also going to be solving one-step word problems involving addition and subtraction within 100 using a variety of strategies based on place value, including algorithms. So right now we're just going to be solving one-step problems. Later on we'll move to two-step problems. In second grade we just stick to addition and subtraction, and right now we're going to stick within 100, but later we'll move to a greater range of number. And again, we want them to have a variety of strategies, and we want to really focus on the place value of the numbers. And we're gonna look at multiple algorithms, multiple strategies, multiple methods of solving these word problems and using this addition and subtraction. We also want students to be able to generate and solve problem situations for a given mathematical number sentence involving addition and subtraction of whole numbers within 100. So again, we're sticking right now within 100, but later we'll move into a greater range of numbers, but we're going to stick with addition and subtraction. But when it says for a given mathematical number sentence, that means that we're going to give the students a number sentence or an expression. For instance, if I said, think about 24 plus 7, and then I ask them to generate a problem situation. Basically, what I'm asking them to do is to come up with their own word problem that would be solved by 24 plus 7. So they could generate it by writing it or just by saying it orally. So if I wanted to create a word problem that matched 24 plus 17, I might say Lauren had $24 in her banking account, or savings account. Her mother gave her $17 for her birthday, and Lauren put that money also into her savings account. How much money does Lauren have in her savings account now? So I have generated a word problem that matches that expression, 24 plus 17, and now I actually need to solve it. I need to be able to add 24 plus 17 and find out what the answer is, 41. The same thing with a subtraction expression. I need to be able to create a word problem that matches the expression that I'm given, and then I need to be able to solve it. Additionally, I need to be able to represent and solve addition and subtraction word problems where unknowns may be any one of the terms in the problem. So I might be asked to solve 24 plus 17 equals question mark, or maybe I'm going to be asked to solve 24 plus question mark equals 41. Or maybe question mark plus 17 equals 41. So the unknown can be in any of those positions, and we have to know how to represent that also. And we're going to be talking about that in a few slides later. So non-standard algorithms, just to reiterate, they really develop number sense, and they keep the place value of numbers. They keep the value of numbers. They don't just become digits where we don't really think about what the digits mean. And also, when we're using these non-standard algorithms, there's many of them. And so there's more than one correct way to approach a problem. And we let the students choose the way that makes sense to him or her. Now, when we're learning a new strategy, we may say, on this particular problem, I want you to use this strategy, just so they can try it out and see how it works. Because you can't, if you've never tried it and you don't know how it works, you can't make a decision about whether or not it makes sense to you and whether or not it's helpful and when it might be helpful. So at times we're going to direct them to use a particular strategy to try it out and see how it works. And then, eventually, as they get more and more tools in their tool belt and more strategies and algorithms that make sense to them, then they will be able to look at a problem and select which method, which algorithm, which strategy makes sense for this particular problem. Because we're really trying to help the students to develop more mental math facilities so that they can have greater number sense and be able to work with numbers in a variety of ways mentally. And also, we're going to talk about notation, because sometimes when we're using these non-standard algorithms, we need a way to put down our thinking on paper so that we can keep up with what we've been thinking, and also so that someone else could look at our notation and track our thinking and see how we solved a particular problem. So here is a problem that's being solved with a non-standard algorithm. And on the right side of the screen are some different methods of notation to show two different ways to solve this problem. So in the first one, we're looking at 37 plus 7. And the first thing that might pop into my brain is that 7 can be decomposed or split apart into 3 and 4. And I know that 7 and 3 go together to make 10. And so I know that if I add 3 to 37, that's going to get me to a multiple of 10, to an easy to use number. So that's the first thing that I'm writing down is 37 plus 3. And then I put an arrow and wrote 40. Because in notation, a lot of times we use arrows instead of an equal sign. Because if I put an equal sign there, then whatever I put an equal sign on one side of the equal sign and whatever goes on the other side of the equal sign, they have to be equal in value. And if you look at this arrow on one to the left of it, there's 37 plus 3, which has a value of 40. And to the right of that arrow is 40 plus 4, which has a value of 44. So they are not equal. They do not have the same value. So I could not put an equal sign there I put an arrow. And so what that signifies to the students and to me is that I first started thinking about 37 plus 3. And that led me to 40. And then I thought about adding 4 to that 40. And that led me to, for the other arrow, to 44. So now I have solved the problem. It's notation, and notation is very personal. You know, different people come up with different ways of notating what they're doing, and it makes sense to them. The other caveat, though, is we ask the students, if somebody else looked at this, you know, would they be able to figure out your train of thought? On the bottom, there's a different algorithm, a different set of notation for thinking about this problem. So the first part here is thinking that 37 could be decomposed or split apart into 30 and 7. And then further, that the 7 could be decomposed into 4 and 3. So the first thought that comes to my brain is that I could take the 7 that's still left there after the plus sign, and I could take the 3, and I could add those two together, and that leads me to 10. And now that I have that 10, I'm going to take it and add the 30 to it. And that leads me to 40. But I still have that 4 left from where I decomposed the 7, so I'm going to add the 4 to the 40, and that leads me to 44. So in both methods, I have ended up with an answer of 44, but I got there differently, a different way. Here's some other methods of notation. You know, you can see the lines where numbers are being combined together. And over there, there's an arrow from the 4 down to 40 to show I'm putting these two together. So that's just a different method of notation that some students have used. We could also do this on a number line. We start at 37 and we do a hop of 3 because I know 7 and 3 go together to make a 10. So that got me to a multiple of 10, which is an easy number to work with. That's why I want to get to those multiples. And so I take the 40, I add the 4 that I still have, and that gets me to 44. Here's another method of notation. Maybe one student's going to take the 7 and 7 and add that together to get 14. And that makes them think about the fact that 14 can be split apart into 10 and 4. So they're going to take that 30 from 37 and the 10 they just made from decomposing 14, put those together and get 40. And then they still have that 4 left over from where they decomposed 14, and they add that to the 40 and get 44. Here, 36 and 28, we're adding them. So we can decompose the 36 into 30 and 6, and then we can decompose the 28 to 20 and 8. And then I see that 8, and I think, well, if I decompose the 6 into 4 and 2, I could take that 2 and 8 and put it together, and that makes a 10. So maybe I do 30 plus 20, and that leads me to 50. And then I'm going to put together that 8 and the 2, and that leads me to 10. So I'm going to put that 50 and that 10 together, which leads me to 60. And then I still have that 4, and I put those together, and that leads me to 64. There's a different method on the bottom, but the same kind of idea. And again, we're using the notation with arrows instead of equal signs because we're cognizant of the fact that if we put an equal sign, what's on both sides has to be equivalent. I could use a number line. You know, I'd start at 36 and take a hop of 20. And then I land at 56. And then I know that 6 and 4 would get me to a 10. So I take a hop of 4 and get to 60, and then use the other 4 to get to 64. A different way, using an open number line at the bottom. I can do the same kind of thing with subtraction. You see the same thing where I'm using, I'm showing where I'm decomposing numbers, and then I am using the arrow to show that I went from this thought to this thought. I can use an open number line. The only thing is with subtraction, we're starting on the right and we're moving to the left because we're taking things away. And when you're taking things away, the numbers are moving to the left. Here's a different notation for 35 minus 18. 35 minus 18 on a number line. And again, we're trying to make those jumps to multiples of 10 because they are friendly, easy to use numbers. You can go to the CSISD curriculum website and click on math, parents and resources, and you will find lots of great resources there.